Hello everyone, welcome to the next lecture on the numerical analysis. Today we will discuss about composite trapezoidal rule. We will explain with some theory and then later on we will discuss the 12 examples so that you can easily understand it. Myself Dr. Harish Garg, you can simply follow my YouTube channel where you will find the playlist of the numerical analysis and the MATLAB code. Here you can find the complete numerical analysis course related to the linear as well as interpolations. And you can see there is a MATLAB code of this composite trapezoidal rules and the others are already available. So let's start with this video. So what is the purpose of this numerical integration and why we need them? So we all know if your f is a differentiable function and its derivative is my small fx, then you can simply integrate this function and define like here. And this result is called as fundamental theorem of calculus. Fine. So it means by using this fundamental theorem of calculus, you can easily integrate as well as differentiate the functions in a simple manner. But there exist many integration or the many function which cannot be evaluated by using this rule. For example, here, if I consider this is my function, can you find any of the function capital Fx whose derivative is my here? You are unable to find that. Fine. So it means how you can integrate this function. So that is not possible analytically. So in order to overcome this, we will use the numerical integration. So that means this numerical integration is successful on all those cases where the integration is not possible here. Like you can see integration of root sin x. It is not possible, you can do it by analytically. So hence it is difficult to evaluate this integration. So for overcoming this drawback, the numerical integration, it is also called as a numerical quadrature, is used to solve such problem. Remember, it is a iterative approach. What is the meaning of the iterative approach? You can find firstly the x0, then you can update the value of x0 by x1, then x2 until you will get your desired accuracy. Now since we are talking about the integration, so our purpose is to integrate a to b f of x dx like of here. So what is the meaning of that? You have to find the area under the curve this from a to b. That is the meaning of this integration. So if you are unable to integrate this function, then we will use the numerical integration. How you can do? So we will discretize this domain, that is b, a to b, into the finite number of these subintervals. Like if I divide this interval into here, I can divide this interval here, I can divide this interval here. So I called as this is my x0, this is my x1, this is my x2 and so on, and this one. Now first of all, this length x0 minus x1, x2 minus x1, they are all is my equal interval. Then the process or the technique which are used for consisting these equal interval is known as Newton-closed quadrature formula. And there are many approaches involving under this, such as trapezoidal rule, Simpson 1/3 rule and all. So in this today's lecture we will describe the first method, and the subsequent later lecture we will describe each of the one in the each respective video. So what is the trapezoidal rule? Basically the trapezoidal rule is a numerical integration method and it is used to calculate approximate value of this integration. How you can do that? How this composite trapezoidal rule are there? Now you can see you have discretized the domain from x0 to xn. Fine. Then if you are joining these points by the straight line, if you are joining these points by straight line, then the method is called as composite trapezoidal rule. Instead of the straight line, you can join this through curve like of this. Then we call as the Simpson 1/3 rule that we will discuss in our next lecture. But right now, if we are joining these points through the straight lines, then we call as the composite trapezoidal rule. And our target is to find the area under this curve over here. How you can evaluate? That's a very simple. If I firstly find, if I call this is my area A1, this is my A2, this is my A3 and so on. So the total integration from this is nothing but a1 plus a2 plus so on. So if I consider the first interval, that is x0, x1, fine, that is my n is 1, there is no sub interval here, there is only one length. Then your target is to find here. How you can find? The first method is you can calculate the value of the y. Can you find this coordinate is my x0, y0, this coordinate is my x1, y1. Can you find the equation between them? You can simply write y minus y1 is slope x minus x1, fine. So I can find the value of y and substitute here. Otherwise, we all know, if we look about this diagram, it is look like, say, here. You know what is that? If I call A, B, C, D, so this is called as trapezoidal, fine. So what is the area of this trapezoidal? So that is a half sum of the parallel sides. So AB plus CD, these are the sum of the parallel side, into the height of this. If I call as E, then the height is my DE. The same for here. If you look about this, instead of the integration, you can simply write half. What is the H? What is the parallel side? This is my parallel side. The length is my y0 plus the length of this is y1. And what is the height is? This is my height. Fine. So if that is a x1 minus x0. So if I consider the length of the each is equal interval, fine, this is my assumption. You can see they are joined through the equal intervals. So if I consider the equal interval length is my h, so that means this is my h. So I can say this is my h. So I can say h over 2 y0 plus y1. Similarly, if I consider this one, then how you can find, instead of this, if I consider this one, then again it's a trapezoidal. So the area will be half the length of the parallel sides. These are my two parallel sides, y1 plus y2, into the height of this, that is a x2 minus x1. Again it's a h, and so on. So this is my area, this is my area, and so on. So I can find the last area like of this manner. That is a yn plus yn minus 1. This is my yn divide into the height of this. So height of this is my h. Now if I join all those, then it will give you the area under the curve from A to B, or from the x0 to xn. And if I add them on the right hand side, what will happen? y1 is a double, y2 will be a double, yn minus 1 will be a double, and the first term and the last term are my single terms. So the y0, yn are my single, and the rest all are my double. And this formula, where is the h is? H is the length of here, and this is called as the composite trapezoidal rule. What is the n is? Number of the sub intervals that you are dividing this area, like here 1, 2, 3, 4. So if I consider 1, 2, 3, 4, so n is my 4. If I consider n is my 1, so what will happen? This is nothing but my y0, this is y0, and this is y1. So that is called as, if I consider n is 1, then we can call as a simple trapezoidal rule, and clearly says when n is 1, h will be my b minus a. So this is a brief theory about that. So we can use this formula for finding the composite trapezoidal rule. If somebody asks you solve the problem by trapezoidal rule, then we can simply take n is my 1. And what is the f of a? That is a lower limit plus f function value at the upper limit. What is the f of x is? F of x is nothing but my this 1. Now I will explain you through these several examples. Look at that. They are talking about the trapezoidal rule, not the composite trapezoidal rule. But the step size is given to you. Step size means h is given to you as 0.25. H is my here. If you compare this function with f of x dx, this is my a, this is my b, then your f of x will be 1 over x plus 1. Now a will be 0, b will be 1. So always draw that table. Firstly, starting value 0, step size is h is my 0.25, so you can add them 0.25 until you will get as 1. So 0.25, 0.50, 0.75, 1.0. Fine. Now, so also you can see what is the value of the h is b minus a over n, or n will be my here. I can substitute the value of h, a and b. You will get n is 4. So you have the 4 intervals. The number of these are my 5. 5s are my data points. 5 is my data point. N is equal to 4 means that is the interval. So first interval is 0 to 0.5. Second interval is 0.5 to 0.50. Third interval is 0.50 to 0.75. And the last interval is, you can see how many intervals are there, 1, 2, 3, 4. Now you can find the value of the fx by using here, like when x is 0 it will be 1, when x is 1 it will be 1.25, it will be 1.50, it is 1 plus 0.75, it is 1 by 2. You can round off to the decimal places, you can get here. Now since h is my 0.25 and n is not equal to 1 because n is my 4, so we can apply the composite trapezoidal rule. So that means I can use the y0, y1, that is the first and the last element as here, and the rest of the elements are my double. So if I, what is the h? H is my 0.25. If I substitute this value here, you will get the right answer as 0.6970. Remember, this is not the exact answer, this is the approximate answer because we are using the approximate numerical integration. Okay, now again the trapezoidal rule, but taking the n, that is a 8 sub intervals. So what is the and correct? So is it a n? Is a sub intervals. Okay, so n is 8 given to you, but h is not given to you. Fine. Now since n is not equal to 1, so we are using the composite trapezoidal rule. So what is the a? A is my lower limit, b is my upper limit. What is my fx? The function value log 10x. Fine. Now you have to make the table x and y is equal to fx. So starting point is my 2. H, what is the h? We can found them, b minus a over n. So b is 6 minus 2 over 8. So that is a 0.5. So we can add the 0.5, 2.5, 3.0, 3.5 until we will get the upper limit as 6. So we will get as, this is my here. Now corresponding to x, we can substitute the value here. We can find the value of y. Similarly, when you substitute x is 2.5, we can get the value of y and here. Now since n is my not equal to 1, so we can use the composite trapezoidal rule. We can use this formula. I can take the first value and the last value as such, and in between this value multiply by 2 by using this rule. What is the h? Is my 0.5. If I substitute all these values here, you can use your calculator, you can get the result up to the 5 decimal places is the required answer. Now in this case we are talking about the composite trapezoidal rule. So that means n is not equal to 1. Fine. What is the a? A is my 0, b is my 6, f of x is 1 over 1 plus x square. Then your h will be b minus a over n. But what is the value of the n? It is not given to you. So that is, now once it is not given to you, then it's on your choice whether you want to take n is 3, whether you want to take n is 2, but make sure n is not equal to 1. Whether you want to take n is 4, whether you want to 5 or 6 as on your choice. So remember, the larger the value of the n, when you take the larger value of n, you will get the closer, you will get the near to the exact answer, near to the exact integration of the answer. But if you take n is my 2, then definitely that's n is very small, then you will not get your exact answer. That's the error will be high. When you take n is small, the error will be very high. So that now it's on you. So I can divide, since it's a, what is that, my h is b minus a over n. So b minus a is 6 over n. So I can choose the value of n is my 6, so that I have taken the 6 subinterval. If you choose n is my 7, then this number will be 6 by 7. That's a fraction decimal. So in order to avoid this, I can divide this into the 6 interval, so that h will be my 1. Now when x is equal to 0, I can substitute here. The answer is 1. When x is 1, it will be my 1 by 2, and so on. You will get these are my values of 1. Now n is my 6, fine, which is not 1. So we can apply the trapezoidal rule as here. y0, this is my y0, this is my y1, and up to same y of 6. The first value and the last value as such, and the rest of the elements is multiplied. Now since h is my 1, so I can substitute h here. You will get the required answer here. Now approximate this integration of this by the non-composite trapezoidal rule. What is the meaning of the non-composite trapezoidal rule? You have to take n is 1. Fine. A is equal to 0 given. B is given to be here. What is my fx is? X square ln of x. Now n is my 1 given to you. So what is my h? B minus a over n. It will be 1.5 minus 0 over 1. So 1.5. Fine. Now you can make the table, or because this is non-composite, so n is 1, so you can start with the lower element and the upper element. What is the h? H is my 0.5. What is the f of 1? Since this is my here, so ln of 1 is 0, so you can say this value. This value we all know is a 0. We can compute this value from the calculator, and you will get this is the required answer. Now they are also talking about the error bound, because n is a very small number, you have picked that, so definitely it has an error. So what is the error? You can find the error. So we all know how you can find the error. Error is nothing but true value minus approximate value. Fine. So this value we have computed by trapezoidal rule. So this value is my approximate value. Then how you can find the true value? So you can simply integrate this function. So we can find this. How you can integrate this? You can use by parts. First function, this is my first function, integration of second function. So I can see, I can take the first function, integration of second function, minus integration of first function and then second function over the dx. This is the limit from 1 to 1.5. So this is x cube ln x over 3 from 1 to 1.5, and this is the x square. X square integration is x cube over is x square is a cube, so it's a 9 from 1 to 1.5. Now you can substitute the upper limit and the lower limit, you will get this is the answer. Now this is the exact answer, this is the approximate answer. You can find the error as exact answer minus approximate answer. So you can see it is around 16.77% of the error when you take n is 1. You can solve this problem by taking n is on your choice, b minus a over h. Fine. So you can say 1.5 minus 1 over h something. You can see if you take n is 4 or n is 5, then definitely if you compute the error, it will be less than of this number. Definitely less than of this number, and that you can do it by on. Okay, what is given to you? Suppose the values are given to you. Find the value of this alpha if the composite trapezoidal rule, that means n is not equal to 1, it is already given, this value is given to you. Fine. So you can firstly make that table. This is value given to you, and your target is to find this number. Fine. Composite trapezoidal rule is given to you. What is the a? The lower limit is 0, upper limit is 1. What is my fx? Fx is not given to you. H will be my b minus a over n. So b minus n is my 4, so that is a 0.25. Now they are talking about the composite trapezoidal rule, we can apply here. this value on the left hand side is given to you as 1.75. H, what is the H? H we computed as 0.25. So this is my 0.25. What is my y0? Y0 is my 1, yn is my here, and this will be my double. Now you can easily find the value of the alpha from here. You can simplify it, okay? Then I think you can easily solve this value. This is divided by here 8 plus 3 alpha, and from here you can easily find the value of alpha by using your calculator. So alpha is my 6 is the right answer. Okay, now look at this one. You have to find the area bounded by the curve. What is the rule of the area? Area is y into dx over the domain x0 to xn, or a to b. Instead of this you can say a to b. Fine. So what is that? This is my lower limit a, this is my upper limit b. Now in this case already a table is given to you. Can you find the value of the h? You can see what is the difference is. The difference is my 0.01. Can you find the value of the n? There is no need, already you can compute from here, but you can see the value of this from here. This is h minus b minus a divided by h. So now required area is my this. So this value h is my 0.01. Now I can use this value. So this value, first value is my y0, this is my y1, last value is my y of 6 because n is my 6. Now you can substitute this value in here. This is my first value, sorry, this is my y5. If first value is my y0, this is my y, sorry, if this value is my y0, this is my y1, this is y2, this is y3, this is y4, this is y5. So this is my y5. Fine. So this is y1, y2, y3, y4 and y5 is there. After the calculation you will get this is the right answer. Now you can see that they are talking about evaluate the value. They are not talking about you can use the composite trapezoidal rule. It means you may use either as a composite trapezoidal rule or a simple trapezoidal rule. Like whether you can take n is not equal to 1 or you can take n is 1. That's on your choice. Fine. So what is that? F of x is my this, a is my 4, b is my 5.2. So h will be my b minus a over n. So that is my 1.2 over n. Now n is not given to you. So if you choose n is 1, then it is called as trapezoidal rule. And since n is a very small number, so definitely the error will be high. So it's on your choice. If I divide this h interval into the 6 part, so that error will be minimized, we can formulate this table. I can substitute these values of the x in this function, then you can find this value of y as here. Now since n is my 6 which is not equal to 1, so then we can apply the composite trapezoidal rule. Fine. So we can substitute this value here, y6, y0, all are my yi's. You will get this is my required answer of this problem. Okay, now you can see approximate the value of I by using the trapezoidal rule. So again you can see you are unable to integrate it exactly. Now they are talking again by trapezoidal rule. Again the value of the n may be 1 or may not be 1 because they are not talking about composite trapezoidal rule. So it's on your choice. If you take n is 1, then it will be your f of 0 plus f of 2 into h by 2. Fine. Otherwise if you take n is not equal to 1, then you have to make a table and solve it. Fine. This is my given to you here. A is my 0, b is my 2. So what is my h is over n. So if I take n is my 1, so your h will be simple 2. Fine. And then in that case you are using the trapezoidal rule. So now they are talking about the trapezoidal method, you can use as of this. So h will be my 2, f of 0, this is my fx. I can substitute this value, you will get this is my required answer. You can solve this problem by the composite trapezoidal rule as well. That's an exercise for you. You can solve, you can take h n as per your own convenience. Like what is your h is 2 over n. So if you take n is 4, then it will be my 0.5. That is easy for you. Okay, or you can take n is 8, it will be 1 by 4, that's a 0.25. That's on totally your side. Okay, look at this interesting question. The area A inside this curve is given by here. So this is the area under the curve, because we all know area is my here. So can you find the value of y from here? This is cos x minus x square into dx, and the limits are 0 to something. So that something is called as alpha. So where alpha is the positive root is given by here. And then trapezoidal, you have to apply the trapezoidal rule, find the value of this area by taking 4 subintervals. That means you are using the composite trapezoidal rule. But the question arises, when you take h is here, what is the value of the h? B minus a over 4. What is a b in this case? It's a alpha minus 0 over 4. So but what is my alpha? Is it given to you? No. So it means your first target is to find alpha. Fine. How you can find the value of alpha? Look at this statement. Alpha is the positive root of this equation. So do you know any method which are used to find the root of the equation? Do you know any method which are helpful for finding the root of the equation? Yes, you can use the bisection method, you can use the regular falsy method, you can use the secant method, you can use either as a fixed point iterative method, or you can use either as a Newton-Raphson method. And we all know Newton-Raphson method converges faster if it is convergent. So I can use this find the value of alpha by using Newton-Raphson method. You may apply the regular falsy, you may apply the bisection, fixed point, that's on your choice. Fine. So if I take this, what is the Newton-Raphson method? This is my here. So if I substitute xn, what is the fx is? Cos xn minus xn square. What is the derivative of this? This is my minus sine minus 2x. So I can say it's a minus sine nx plus 2 of nx. So this minus and minus will be positive. Now we all know alpha must be greater than 0. So I can take any of the initial guess, say 0.5. Fine. Then I can substitute this value at here. You will get x1, which is x0 plus cos of x0 minus x0 square sine of x0 plus 2x0. So since x0 is my 0.5, I can substitute here. Make sure whenever you are trying to find the value of the cos 0.5 or sine 0.5, set your angle in the radian in your calculators. So once you can solve, you will get the value of the x1 as here. Substitute this value of the x1 again in this equation, you will get the x2, x3, x4 here. Now clearly says this value is correct up to the 4 decimal places. So then the desired root is my here. Now once you know the alpha, this alpha is my 0.824. Now you can do like this way. What is the A? A is my 0, B is my 0.824, and it is given to you. You have to consider the 4 subintervals. N is my 4. You can find the value of the H is B minus A over N. What is your fx? Fx will be 4 times cos x minus x square raised to power 1 by 2. So this is my fx, this is my h. Now you have to use the composite trapezoidal rule. You have to make the table. X, what is the A is 0. You can take the length is 0.206. Then next one is 0.412. Next one is 618. And the next one is 0.824. Corresponding to this, you can find the value of the fx by substituting the value of this here. Make sure this angle should be set in the radian in your calculator. So you can get these values as here. Now finally you can do the composite trapezoidal rule. This is my y0, this is my y1, last value is my y4. The rest of the number you can add and you can get your answer as this. So this is the way you can solve this composite trapezoidal rule example in a very simple way. We will see the next lecture on the error analysis of this composite trapezoidal rules. Till then, you can simply like, share and comment on my video. Best of luck students. Happy learning.